Now we're going to look at when is it actually a linear model. So in 1.2, we were just talking about how do we find those regressions, regardless of the reasonableness of it being linear, because some graphs aren't linear, right? Sometimes they go up and then down. Sometimes they just go really, really fast up and it's exponential. We need to make sure that it is actually a linear set of data that we're looking at. So in order to do that, we're going to construct a scatter plot and then look at the residual plot. And that's going to help us determine if the linear regression is actually appropriate for the data. So the first thing we're going to do is take all this data and type it in. I'm not going to do that while I'm on a video, so I have already put it into a graph for you. So this is the first set of data. Now, and you just go to Desmos and do what we did last time. I need to find the linear regression, but maybe I want to look at this information. If you come over here to the left side of your Desmos page, you can see zoom fit. So we'll zoom in and hey, we can look at it. Now that right there, this set of data should automatically tell you this is not linear. This is not linear. If you look at this information, you should notice that these points go up. And they go up very quickly. This is not a linear set of data. This is actually what an exponential set of data looks like. However, sometimes it's a little harder to tell. So we want to know how to look at a residual plot to see if the data is actually linear. So we're going to add a regression here, and we're going to make it linear. All right, so here's our equation that it's predicting it will be. Now that it kind of looks like a silly line, but in the midst of those points because it doesn't fit the data. But again, if you're unsure, or if I tell you, right, if your teacher tells you to find the residual plot and figure out whether it's linear based on that, then you need to know how to do it. And it's just by pressing this button right here. So we're going to plot the residuals. A residual is essentially the difference. It's calculating the difference between the point on the line and then that point that you see on your graph. So like the blue point and then that particular y value on that linear equation. And it'll either have a pattern or it will not. So you should notice that these red points, that's a residual. And you see how it kind of makes a weird graph, but you can see like that's a curve. That is a distinct curve. That means because you can see a pattern, there is a pattern of some kind. It's not just a random assortment of numbers that are scattered all over the place. It forms a particular graph. That means that it is not a linear regression. So this is a bad regression, a bad linear regression. So over here on our notes, we're going to say it is a bad regression because, and B-C means because, the residual plot shows a pattern. So we have to check for patterns there. If there's a pattern there, it is a bad regression. If there's not a pattern there, if it looks really scattered, then it's a good regression. And naturally, I'm going to show you what that looks like. So let's come back to our Desmos graph. And fun fact, I've come up with the other one before we had to, right? And you can see this data and you can see this is a lot more linear looking. It doesn't look exponential like the other one did. But if we're ever unsure, we do need to find that regression and look at the residual plot. So we're going to look at the residual plot, and we do need to be able to see the residual plot. So let's zoom so we can see all of that. Okay, so you see how it's at the bottom here, right? Because these are the values. And most of the time it's going to be, here's your data up here, and here's your residual plot down here. And you should see, hey, this is not, it's not a pretty curve that we can follow and sketch the graph. We have a bunch of random points here, which means it's actually a good linear regression, because that means that, hey, look, we're not too super far from those points that we had in green from our linear equation. So this is a good linear representation because it does not, this residual plot does not show a distinct pattern. And if you need to rewatch any of that, you definitely should, and take notes on how to find that residual plot, because your teacher may or may not end up showing you again. So this is good because the residual plot does not show a pattern.